Hello, good day, good morning, good afternoon, good evening, whatever you may be watching this. Good that time. Alright, so here we are. We're going to talk about tangents. Today, the learner will utilize and understand properties of tangents. Yay! I want to go through a lot of examples, so let's get to it! Okay, so earlier you had definitions of circle parts and everything back in part 1. So here we go. What is a tangent? A tangent, again, it's a line specifically. A tangent line intersects a circle at exactly one point. And that point is called a point of tangency. So, like when you look at this, here, AB that line is a tangent line, but the point of tangency is at point A only. Okay, so kind of keep that in mind. All right, now here's the interesting part. A line is tangent to a circle if and only if it is perpendicular. It's got enough space to a radius. Okay. Conversely, in other words, that tells you that if a line is tangent, then you know there's a 90-degree angle here. And the neat thing is, I can make a right triangle. What does that mean? It means the Pythagorean Theorem is coming back to us. So yes, you will do some a squared plus b squared equals c squared. Okay? So, how will I know which one is the c squared? That's what we're going to find out. Okay, so how can I determine? Now, keep in mind, how do you determine? The Pythagorean Theorem not only helps us finding missing side, it can also determine if something is a Pythagorean Theorem. So, A, B, C. C should always be the longest. If I want to determine if it's tangent, then those two should, the 8 squared plus 15 squared should equal 17 squared. Okay, you plug those in, you get 289 and 289. So, yes, that is tangent. Okay, now, I'll do number 2 here. If you do, say, okay, here's where you got to be careful. Oh, this is where we get sneaky on this. A lot of people say, hey, that's just 5. No, it's not. Notice how they wrote that versus here, they made sure you know that 17 covers the whole thing. From here to here is 5. Then what is this? That's 11 because, again, that's the radius. Okay, so reality is this is 16 from here to here. Okay, so I'm seeing if 11 squared plus 14 squared is equal to 16 squared because this is A, B, C. Okay, so if I do it that way, I get this one to be 317. This one to be 256. They are not equal, so no. That one is a no. It is not tangent. All right. Let me zoom in a little bit more for the next one. All right. So now, the easy problem. Okay, so now they're telling us this is tangent, so we are going to have that 90 degrees. And remember, it's always 90 degrees right here. Okay, at that point where it touches the circle. Okay, so, and the way I will always do this is, I will always say the radius is A, from the tangent point to on the outside, the tangent line, that's going to be B, and this will be C. Okay, so in this case, I will go 7 squared plus 19 squared is equal to, say, x squared, and then solve from there. If you take that into, say, 7, that would be 410. And then, of course, take the square root, and you should get about 20.2. Okay? And there you go. So, be careful. I mean, that's the way you should do those types of problems. But again, be careful on a problem like number 4. A lot of people want to say, oh, this is just 7. No, again, if I were to do something like that, guys, I would have done, like, say, a line to make sure you notice. So if this is 11, what is this? It's also 11! So that means from here to here is 18. Now you have to be very careful with it. That's what makes this kind of difficult. You got to pay attention. Because again, here's A, here's B, and this is going to be C. So that means C is 18. Okay? So always keep in mind that C has to be the longest side. So in this case, and I'm always saying the radius is always going to be A, and the tangent line is always going to be B. So that might be something to help y'all with that. Okie dokie. So what I've got here is 11 squared plus x squared is equal to 18 squared. And again, you will say x squared is equal to 18 squared minus 11 squared, which would be, if you type that into the calculator, should get you 203. And then if you take the square root of that, you should get about 14.2. Okay, rounding it off and so on and so forth. So again, the idea here is that we use the different types of Pythagorean theorem to try to make sure we can get the sides and kind of go from there. Originally I wasn't going to do number 5, but then I was looking at it and I was like going, wait a sec, I should probably do that. All right, so again, how's another way I can be tricky with this? There's one way you could try to do this problem, and you might have a teacher try to say, oh, you got to do this whole Pythagorean theorem or quadratic formula thing or whatever. But let's keep this in mind. This is going to be 10, and I'll take care of that later. Here's A, here's B, and again, all of this right here is C. Okay, so here I'm saying 10 squared plus 24 squared is equal to C squared. Okay, that would give you 676, which is equal to C squared. Take the square root. You get C is equal to 26. So this whole thing here is 26. This together, because this would add up to this, would equal 26. So then I can find out that x is equal to 16. Again, how difficult I would say ask y'all to really do this, I don't know. We'll see. But you get the idea. All right, so let's look at another example, number 7. Okay, so how could I do number 7? Well, keep in mind again, here's my 90-degree angle. This time I'm going all the way across. So if this is 3.5, this is 3.5, which means this whole thing is 7. But I'm still going to say that's A. That's B. And this is C. Okay, a little bit different this time, but again, if the 90-degree angle is right here at this tangent, C is always the opposite. Okay, so I have here 7 squared plus 6.4 squared is equal to x squared. Okay, and that should get you 89.96 is equal to x squared. Take the square root of that, and you should get about 9.5. Okay, yeah, and that should be that. And again, if y'all ever can't see how to set up the problem, let me know and we'll go over it. Okay? Okay, so this one right here is pre-AP. This would be like something I would only do for the pre-APs. Because you will see something like this, like in a pre-cal class or something like that. But, you know, hey, those of you all listening to this, go ahead and challenge yourself. How does this one work? Well, this one works out a little bit differently because this time I'm telling you that the radius, I don't know the radius. So A is x, and so is this. That means this whole thing right here is x plus 10. Oh, no. So I have here x squared plus 20 squared is equal to x plus 10 squared. Okay, so this is where something you might see like in Algebra 2. Where you'd have to do something like this, and you would have, say, x squared plus 400 is equal to x squared plus 20x plus 100. Now, if you don't remember how to, say, expand a binomial, you need to make sure you know how to do that. What I do is I take this and go, like, say, x plus 10 times x plus 10, and multiply that out, okay? And do 2-digit multiplication. You might remember FOIL if some of your teachers still use that method, even though I completely disagree with it. Box method, anything like that. There's different methods, and if you need a little refresher on that, check one of my old videos on that, or just ask me. Anyways, if you move the variables to the left, numbers to the right, what I would have here is these x squares would cancel each other out. I would be left with negative 20x, because I'm moving this over here also. And over here, I'd be left with negative 300. So when I divide, I get 15. So it looks like it would be a lot harder than it is, but you kind of get the idea. There's a certain setup that makes that a little bit more difficult. Anyways, not too bad, but there you go. All right, so now we have a couple more little things here to cover. If two segments from the same external point are tangent, so if they're from this point, there's two lines that are tangent, they're congruent. Whoa! If a polygon is circumscribed around a circle, then all the sides are tangent. So in other words, if I draw a line, like any type of polygon around a circle, that its sides are all, so it's circumscribed, that means all its sides touch the circle and thus they are all tangent. Okay? Now what would that mean? Okay, keep in mind, think about this. That means like this and this one are equal, okay? Or these two are equal, or these two are equal. So like keep that in mind. That would help you when you're trying to figure some things out. So, and again, if you're not sure, what do you defer to? You defer to them being equal. So like here, I see two lines that are tangent. So I'm going to set those equal. 8x minus 19 equals 5x plus 23. Variables to the left, numbers to the right. You get 3x. You got plus 19. You got 42. And then you can divide and you get 14. Whoa! Okay, so same thing on number 11. I would set those two equal. 14x minus 13 is equal to 8x plus 5. Oops, there we go. And again, variables to the left, numbers to the right. That would be 6x plus 13 is 18. And then you can divide to get 3. Now they do say find PQ. So then you could put 3 here and say 14 times 3 minus 13 and get 29. But you kind of, it just depends. All right, how about the next one? Yeah, you thought I was going to make you do that one closed in. I zoomed in for you because I am nice. All right, so find SV. But first, they want you to find SV. Okay, so the first thing we want to make sure we do is we set those two equal. All right, so I'm going to say here 10x minus 41 equals 4x plus 7. Okay, so then I would variables to the left, numbers to the right. That gives me 6x is equal to 48. So x is equal to 8. Okay, now, if x is equal to 8, I can put that here and say, put an 8 here. I could put an 8 here. It doesn't really matter. And when you do that, you should get that this line is 39. Could technically be this line is 39 too, because if you know that's 17, this is 17. Okay, so now, again, what do we know? We know that this is a 90-degree angle. So going back to the first set of problems, like what we did at the beginning, I could say 17 squared plus 39 squared is equal to, we'll say, y squared. Okay, and then when you do that, you should get 1,810 is equal to y squared. Take the square root, and you should get about 42.5. I do not know why I was putting the decimal early there. Okay, again, the main idea is know that these two are equal, and then go from there. Okay, don't get lost on like, oh my god, this looks too hard. Go with the idea, can you solve something? Can you solve variables when they're equal? Because guys, I mean, you can gripe all you like, but you're going to be doing that in algebra no matter what next year. So, and at the beginning, and I would, if I was teaching algebra 2, that's what I would be expecting. You can solve equations. No more of this, I don't remember how type of thing. You have to know these things. Okay, last example. Find the perimeter. All right, so again, going back to that last property, knowing that those are, say, going back to here, these are equal. Okay? So if those are all equal, I can go back and do this and say, okay, if that's 16, this is 16. That's 9.5, this is 9.5. If that's 11, there's 11. Okay? And then add. And so like I could say here, 11 plus 11 plus 16 plus 16 plus 9.5 plus 9.5. Ooh, I ran out of space on my thing. Okay, and add all that up, and you should get 73. And that's it. That's all you got to do. Pretty easy, right? So just kind of think of it like that, and you should be just fine, guys. Anyways, let's look at what you need to do for problems. All right, for my CEP classes, I want y'all to do, on the last two pages, pages 3 and 4, 1, 2, 5, 6, 7, 8, 12, 13, and 14. Okay, so make sure you're doing those problems. And then for my pre-AP classes, just 1 through 14. All right, guys, we'll see what we do from there. The next thing we'll cover, I should hopefully have up soon. But if y'all have questions, you know where to reach me. You can reach me on Google Classroom or Remind. Y'all take care, be safe, and just let me know how I can help. Take care.